Welcome back to Factoring Trinomials. There's your recap. Remember, product sum, so we can expand the middle term. Then we have our two sets of binomials, so we can factor, 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 and factor. Okay, here we go. 7p squared minus 9p plus 2. All right, so first we want to product sum it so that we can split the middle term. Okay, so 7 times 2, multiply the ends, so 14. The middle term is our sum, negative 9. So I need the two numbers that multiply to 14 but add to negative 9. If you need the tree, go for it. Positive product, negative sum, these both have to be negative because two negatives will multiply to a positive, but two negatives will add to a negative. Negative 1 times negative 14 is positive 14. If I add those, it's negative 15. That's not what I want. So try negative 2 times negative 7. That's positive 14. Negative 2 plus negative 7 is negative 9. Hey, that's what I want. Okay, cool. So we're going to use negative 2 and negative 7. We use that to break apart the 9p. So we're going to have negative 2p minus 7p. Remember, equivalent. It's still telling you the same story. I'm just making it so that it helps me. Okay, I'm going to bring down the 7p squared, bring down the plus 2, so I have the exact same expression. It just looks a little different. All right, once we're here, we are going to group them into two binomials because we know how to factor binomials. Okay, we're going to look at the first group. So 7p squared minus 2p. All right, so I'm looking, look, you can make the list if you need it. You'll see real quick that like, oh, hey, okay, so this is 7 times 1 times p times p. This is negative 2 times 1 times p. All that they have in common is the 1 and the p, right? So I can pull out p. Then remember, we still want it to be 7p squared minus 2p. It just is going to look different, right? So p, I have to still multiply by the other factors. So p times 7p is 7p squared. And then p times negative 2 gets me back to the negative 2p. All right, let's factor the other side. So negative 7p plus 2, okay? So right now I'm like, wait, like there's nothing in common here to pull out. So I would have plus negative 7p plus 2. Okay, at this point I'm like, wait, what the heck? Like there's nothing in common. How do I create the multiplication problem then? But I don't know. But look how close they look. I have 7p minus 2 and I have negative 7p plus 2. Is there a way I could make those look like each other? And yes, you can. Look, if I pull the negative 1 out, negative 1 times 7p is still negative 7p. Negative 1 times negative 2 would be plus 2. Hey, that's the same thing as 7p minus 2. These are equivalent. They tell me the exact same story, but now I just manipulated it so that it actually benefits me and what I'm trying to accomplish. So I could rewrite this as p times 7p minus 2. Now I'm going to use this right here. Minus 1 times 7p minus 2. Because once I'm here, look, I have 7p minus 2 is being multiplied times each of my terms. So that's my greatest common factor. And we can pull greatest common factors to the front, 7p minus 2. And then to create the equivalent expression, I still have to see, well, what do I multiply that by, right? So 7p minus 2, I have to multiply by p. And 7p minus 2, I still have to multiply by negative 1. There is my factoring. I check real quick. Okay, I have 7 and 2, no common factor. I look in here, I have 1p and -1, no common factor other than 1. This is my final factored form. 7p minus 2 times p minus 1 will give me back to 7p squared minus 9p plus 2. Okay, let's do another one. 2x squared plus x minus 6. First, product sum puzzle. Okay, so multiply the ends. 2 times -6 is -12. The sum is the middle one. If I don't see the coefficient, it's 1. So the sum here is 1. So I need two numbers that multiply to -12. If I add to 1, you can make your list, use the calculator. A negative, so these have to be opposite signs. That's the only way to get a negative product, right? So -1 times 12 is -12. When I add -1 and 12, that's 11. Okay, so not what I want. -2 times 6 is -12. -2 plus 6 is 4. No, I'm going for 1. Remember, 1's my target sum. Okay, -3 times 4, that's -12. -3 plus 4 is 1. Hey! Okay, so -3 and 4 makes this work. So that's how we're going to break apart the 1x. We're going to have -3x plus 4x. Same thing, because 4x minus 3x is 1x. We're just using it to help us factor. All right, so I have my 4 terms, which means I can group it into my 2 binomials and then factor each part. So I'm going to have 2x squared minus 3x. I'm like, okay, that's 2 times 1 times x times x. This is -3 times 1 times x. Okay, all that they have in common is the 1x. So I pull x out, and what's left to multiply, so I still have 2x squared minus 3x. Okay, I can't change the value of my expression. So I have to multiply x times 2x so that I end up back with 2x squared. And then x times -3 so that I'm at -3x. All right, let's do the other one. 4x minus 6. Okay, so if I'm looking, you could do your tree, 1, 4, 2 times 2, 6, we have 1 and 6, 2 times 3, right? Okay, so I'm seeing 2, right? This is 2 times x. This is 2 times -3. Pull out the 2, so plus 2. And then what's left? I have to multiply 2 times 2x so that I get back to 4x. And then 2 times -3 so that I get -6. Okay, cool. Now I look and I say, hey, I'm adding 2 terms, but look, they both have 2x minus 3. So I can pull that out as my common factor. And then see, okay, what's still left to multiply? 2x minus 3 is times x. 2x minus 3 is also times 2. Those are my other factors. I look inside, okay, 2 and 3, no common factors. 1x, 2, no common factors. I am done. There is my factored form. When I multiply those two quantities, I will get 2x squared plus x minus 6. And check out another video for more examples.